start paying attention. I'm going to show you something right now, and I'm going to ask you a question after you see this very, very short videos. The video is just like 1 minute. I'm going to ask you one question after I finish this video, okay? Okay, so my question for you is super simple. Do you see any difference between this scanner and the one that I started my class with?
This one is mobile.
It moves, yeah.
Thank you so much. This is really the word I wanted. This laser scanner is in motion. And now I'm going to show you that only this small difference will make a huge difference between what you've seen in the past, like in the first part of my class, and this one here. So let's say this is a ground-based laser scanner, but it's kinematic, huh? So which means the scanner is in motion. Let me iterate and remind you, okay? So if you go back to our scanner, this picture here, yes, this one here. So you can see here, my scanner is static. It's set on a tripod, and then the mirror oscillates, and the laser scanner rotates about its vertical axis, and then creates a 3D point cloud. Remember that all the points within the same point cloud, they come from the same point, from the same XYZ, because my scanner is static. It doesn't move. And this is the huge difference between a laser scanner that sits on a tripod and a laser scanner that sits on top of anything that's moving, which could be a car, could be a van, could be an aircraft. Doesn't matter. The platform that carries the laser scanner is in motion. And the big difference is when the laser scanner on a moving platform, it means it keeps emitting laser pulses, however, not from the same point because the laser scanner is in motion. Do you guys agree or disagree?
I agree.
Okay, so again, how can we solve this problem now if my platform is in continuous motion and I still want to find the X, Y, Z? Okay, so here is another system, and you can see this system right now. My laser scanner is not on aircraft, sorry, not on a moving car or van. However, it is simply on a moving aircraft. And so maybe I have another animation for you. And you can see my system. It has a laser scanner which pulses laser beams into the ground, and we have oscillating mirror that simply diverts the beam across track. And while my aircraft is moving forward, you can simply get continuous like a carpet on the ground. Hopefully, you guys can see this pattern of survey. But the thing is here is that now, as I said, let me show you my pointer. So again, look at this. Huh? So this point here, which is where the laser scanner pulse emits, is in motion. And to find the XYZ of these points on the ground, what do I need? For sure, I need the range, the distance. I also need some direction, some angles. But that's not enough because I need to find how much is my X, Y, Z here when I pulse my laser scanner. To find X, Y, Z on the ground, XYZ on the ground, you need for sure the range, the distance. You need some angles here, and also you need the XYZ. And that's why if your platform is in motion, you need something else. And this another sensor, it will simply gives you the X, Y, Z as a moving platform. Can you guess what can we do that? How can we do that? What kind of sensors that we need to include to continuously track where is my laser scanner? You've seen it in the video. I'm going to go to the video and you see it in this picture here. What do you see
Yeah.
in this picture here that gives you the XYZ of where my laser scanner was?
Is it GPS?
The GPS antenna, you can see. So you can see here we have a GPS antenna here, this GPS antenna. And what it does, it simply finds for you the location of the sensor XYZ continuously because it's in continuous motion. Okay? But that's not enough. So the XYZ for sure is a mass, is required, and but not enough because we need also to know the orientation because my car goes east and west, north and the south, up and down. So what does it mean? It means the altitude, the orientation of my laser scanner change in the space. Did I teach you anything in this class? If you remember, anything, any sensor name that finds the orientation of something in space? Did you learn anything in my class? That wasn't photogrammetry, by the way, if you remember, when we talked about those mobile mapping system, that they are a set of cameras on top of a van, and the van drives on the road, and we can collect georeferenced image. Did I? Go ahead.
Accelerometer?
Say it again.
Accelerometer?
Yes, sir. Thank you so much. So not really accelerometers. It is called INS or IMU. Remember those names, which is simply a combination of 3 accelerometers plus 3 gyroscopes. And what they do is same as the ones in your cell phone. What they do is they find the orientation of your sensor. So here is my discussion for you, my final discussion. So if your sensor is in motion, it means it's a kinematic application. It means I need GNSS or GPS. And what it does, it simply finds for you the position of your sensors all the time. In addition to the IMU, which is inertial measurement unit, or INS, which is inertial navigation system, which basically they are the same thing. And what they do is define the attitude, which is the orientation of your sensor. Without this, without those sensors, guess what? We cannot find XYZ, the laser scanner. So here is my final comment for you. If your sensor is on top of a tripod, no need for GPS or no need for INS. No need. Once the sensor is in motion, when we place it on a moving vehicle or even like aircraft, in this case, you must add extra sensor. And those sensors are, I need GPS or GNSS receiver in addition to IMU. And this creates a system, and in this case called the LiDAR system. So now you hear two names, a laser scanner and a LiDAR system. A laser scanner and a LiDAR system. A laser scanner is just by itself, just a laser scanner, just like total station, and it's okay for static application. Once you start moving the sensor, laser scanner by itself, it doesn't work. We need to add more sensors, which is GPS and INS. And the combination of the three of them called LiDAR system. And LiDAR is short for light detection and ranging. So if I ask you a question and tell you, is laser scanner equal to LiDAR system? Those are equal? They are not equal. Laser scanner is only one component of the LiDAR system. LiDAR system, we need to add on top of the laser scanner, we need to add a GPS and an IMU or INS for obvious reason, to continuously track the position and the orientation of the sensor. Now I'm just did some research and try to find for you the kind of latest airborne scanner system. So Leica has one system called City Mapper 2, and simply you can place this scanner on top of an aircraft, and it simply creates city models. You can see here, probably this picture can tell you something. So if you have downtown and you want to create a 3D model for downtown Calgary, for example, you want to fly with this system here, and simply it creates for you a 3D model of, for the city. Now, here are some specifications for the system. You know what? Some of them probably is, you can read easy. For example, laser wavelength. So the wavelength is 1064 nanometer, which is 1.264 micrometer. The repetition of the pulse, which is the frequency, called frequency, up to 2 megahertz. And what does it mean, 2 megahertz? It means 2 million points per second. So every second, the system can survey up to 2 million points. Now, we also have some stuff like, for example, if you remember from my photogrammetry class about satellite image, we talked about digitization. We talked about 8-bit scan and 11-bit scan. Now in this system, it has 14-bit scan. The operational altitude from 300, so you can use it from 300 meter all the way to 5.5 kilometer above ground. Okay. The field of view is 20 to 40 degrees. And if you ask what is the field of view, I can go back a little bit and show you what is the field of view. So you can see the angle, this angle here is called field of view, just like a camera, which is how wide you can see field of view, 20 to 40 degrees. Other specification, for example, we have here accuracy of 5 centimeter for vertical accuracy, so that when we get elevations from my model, it is plus or minus 5 centimeter. And then if you go to horizontal coordinates like easting and northing, it will be within plus or minus 13 centimeters. Okay, so those are kind of a specification that I wanted to go through with you. And then also here is the product. So on the right side here, this is the product of an airborne laser scanner. It gives you simply XYZ, and you can see the heights. While on the left here, this product here is done by aerial camera. So that you can see the difference. This one contains only XYZ information, while this one contains color information. Now, there is something, now you've seen two systems, a camera, which we use it in photogrammetry, and a laser scanner. I want to show you one major difference between camera and laser scanner. And we talked here about something called active sensor and passive sensor, active and passive. And I will show you what does it mean. So let's look at what happens when I am using my laser scanner. See what happens? Here we go. So this is my ground. I'm trying to survey this ground. Okay. And here is my sensor. That's my laser scanner. And here is a point called A on the ground. You know what happens? When it comes to LiDAR system, it simply has a battery. It creates its own energy. It emits the energy towards the ground. The pulse will hit the ground and it will be reflected back to the sensor where you can find the distance and you can find XYZ. And that's why radar and LiDAR system or laser scanner, those are active sensor. What does it mean? It means they create their own wave and energy. How about the camera? The camera, does it work this way, the same way? No, it doesn't work this way. So the camera, same idea. Here is my ground. Here is the reality. Here is my camera. Here is point A. And what happened here? The sun or some source of light will simply generate the energy. The energy will travel all the way to point A. The energy will be reflected where the camera will simply record the reflected energy, which means if you are at nighttime, it means you can not take photo at nighttime because simply there is no reflected energy. And that's why cameras are passive sensors. Now let me ask you, which one is better, passive or active? Any thoughts? Which one is better, passive sensors or active sensors?
Active.
Oh, you know what? I can get you why you're saying active, which kind of I agree. Active sensors are amazing because simply they don't wait for the sun. They can do the survey without the sun. They can do the survey even at night. So I can simply have my laser scanner at night. It will give me XYZ. I can simply fly my aircraft with a LiDAR system at night and I can get my XYZ. So that's amazing, huh? I don't need for the sun. The camera, because it's a passive sensor, it has to wait for a source of energy until it lights up the scene. So I agree, active sensors are better because simply they create their own energy and no need to wait for the sun. For example, I'll take you to some application. What if I do survey inside a mine or tunnel? Can I use surveying? Can I use photogrammetry? I'm sorry. Can I use photogrammetry when I survey a mine or tunnel?
No.
No.
Yeah, your answer is perfectly right, because simply it's too dark, whether in the tunnel or in the mine, and you cannot use photogrammetry. While laser scanner, because they don't need any light, they can operate in a very dark and they can still give you XYZ. However, I'm going to show you another phase of the story, which probably you never thought about it, which is not really easy. When the laser scanner is, because it's active sensor, it means I need a source of energy for the laser scanner. When your laser scanner is on the ground, great, that's easy, because all you have to do is you have a power cable. You can hook your power cable to any source of energy, like an outlet, and you can work for 1 or 2 or 20 hours, doesn't matter. Would you agree?
Yes.
Now, when the sensor is in the air, let's say in aircraft, if you think about it, you will see I need a battery big enough to operate the system for hours. And that's really need a big battery. And that's why for how many years the system, the airborne system, it was heavy and bulky because of the battery. And that's why we couldn't use the LiDAR system with drones, because drones, they are not really big. They can carry a level as like small weights, which is okay, but not big weight. And that's why they can carry a camera, but they cannot carry a laser scanner. But you know what? Over the last few years, there are so many things are changing. You guys have seen it, huh? Like look at Tesla when they are creating those electrical cars. Really, there is right now, there is big research on how to make our batteries more efficient, more compact, so we can travel for longer distance. Anybody knows how long Tesla can travel on one single charge?
700 miles.
Oh my God, see? And by the way, they start from very low. They started only, I think 300 kilometer per single charge. Now you can see a 700 mile, that's more than 1,000 kilometers. So you can go from Calgary to Vancouver with only one charge. That's exactly what's happening. We're getting better battery to the point that right now we have LiDAR system that can use a very small battery, that we have drones right now, not really very small drone, but medium-sized drone. They can have a LiDAR system on board, not only cameras. Anyway, I'm happy with this level of discussion. Let's move on to our last part of our class today. Okay, I have a very interesting video for you, very interesting, by a very funny guy. Uh, he will simply make a small comparison between photogrammetry and laser scanner, very entertaining. And although it's not really perfectly fit in our class, because you will see he's going to make some demos on robot toys and stuff like that. But all he's going to say is absolutely true and applies in surveying when we survey, like, let's say, the city. Let's watch the video and let's get some discussion running after the video. Watch this.
Over the years, two main methods of 3D scanning have become popular, and for good reasons. They work, and they work very well within their parameters and what is expected of them when they are properly understood. For those of you who come to this video wanting to get a short answer, I will say this: photogrammetry for the win. Now for the rest of you that wants to get into the juicy details as to why and when to use which, you will find the rest of the video very entertaining, but only for those who really wants to know. Photogrammetry works by taking multiple photos of the same thing from different angles and having the computer detect overlapping patterns and build up a 3D reconstruction of that which has been photographed. As you can see here, it's pretty terrible at reconstructing smooth, shiny, perfect, featureless surfaces that have little to no details. So you can forget about using photogrammetry on your plastic toys with large flat surfaces consisting of a single color. There are no visual patterns to detect. Photogrammetry and smooth, featureless, shiny surfaces are not friends. This is the only real limitation of photogrammetry, the only one that truly matters. However, it can be easily fixed. All you have to do is to mess up the surface so that it is dirty, messy, gritty, and not shiny. For my robot toy, I sprinkled baking soda on the black surfaces and used a whiteboard marker to mess up the smooth white surfaces. Taking multiple shots of the same toy again and with the magic of photogrammetry, these are the final results. There are two results here because I've decided to do it twice separately, taking two separate sets of photographs. The results are absolutely amazing, and not just visually, because anyone who is into 3D modeling knows good texture can often cover up bad mesh geometries. Now look at the mesh geometry without the textures. It's good for a scanned surface. It's never going to be as perfect as a 3D model modeled from scratch, but it is really good for a scanned. I would even go so far as to say that this is the upper echelon of 3D scanning regardless of what technology is being used. Now let's talk about 3D scanners, devices that use methods other than photogrammetry to obtain geometric data. For the purpose of this discussion, the type of 3D scanners I'll be focusing on are $250 scanners you can buy at your local computer stores or eBay. I understand that there are 3D scanners out there that cost upwards of $10,000, some even $20,000, but I don't exactly live in a mansion and I don't own a private jet. So, if any of you out there have spare $20,000 floating around, please send it to me.
I mean the cash, not the device. Now back to the discussion.
Consumer-grade 3D scanners use infrared light projection to construct geometric data from whatever they are scanning. That means they can work in the dark. That means no special light setups are needed. Please understand that that does not infer that photogrammetry requires special light setup. For photogrammetry, as long as there is enough light for your camera to see the patterns, you are good to go. Sunlight is enough, more than enough. Because of the ability to scan in the dark, 3D scanners are very useful for cave scans or any area where not enough visible light can reach. But for most consumer purposes, let's do a few scans and see the results. The reason I have to do a few scans instead of just one or two is because the result from consumer level 3D scanners are usually so bad and unusable that you just have to do it a couple of times and pick the one that is actually usable. 65% of the time, the reason why most people get terrible scan results from their consumer level 3D scanner is because they did not specify to the software the area to be scanned beforehand and the level of density the scan mesh should have. If you set the area to be scanned much larger than it needs to be, the density of the mesh will be spread out and the detail you end up having for your intended object will be nearly non-existent. If you set the density of the mesh too low, there is simply not enough points to describe the detail of your intended object. There is another major concern when it comes to using a 3D scanner. Most consumer scanners can only scan details down to 1 to 2 millimeter. If your subjects have details smaller than that, you can kiss your 3D scanner goodbye. If you set your consumer-grade 3D scanner parameters correctly, you can aim to achieve about 30% of the quality you can get from photogrammetry. Here are the 4 scan results from 4 separate scans of the robot using a consumer-grade 3D scanner. Here again are the 2 results from photogrammetry. Now let's compare the best of the 2 methods next to each other. In this case, there is no comparison. It's very clear who the winner is here. However, before any one of you want to boo the consumer 3D scanner, remember, photogrammetry would have given us nut have we not messed up the surface pattern of the smooth, featureless plastic. And there will be times where you are not allowed to desecrate the surface of whatever you are scanning, and where it just so happened that whatever that is happened to have shiny, perfectly smooth and featureless surfaces. Under those circumstances, you can say goodbye to photogrammetry and hello to your 3D scanner.
In time, 3D scanners will get cheaper and the resolution will get better. But for now, all things being equal, as far as quality is concerned, both in geometry and texture, photogrammetry reigns supreme. And it's just such a bonus that it happens to be the most accessible. Everyone have a camera phone. This is Bracer Jack, signing off.
Okay, so as I said, although this video doesn't apply too much to photogrammetry, because you can see like robot toys, and we're not really doing robot toys in photogrammetry. We use it to survey the ground and create maps, but it still doesn't change the fact that photogrammetry is not a friend with shiny, featureless surfaces. And if we apply this in our domain in civil engineering, I'm asking you, can we use photogrammetry to survey an area covered with snow?
No.
No, you cannot. And again, at the end, this guy, he talked about that Bryce also plays part of the game, because photogrammetry is very accessible because you can use like your even your cell phone camera. However, I have a news for you. Okay, let's watch this. You will be amazed of the laser scanner offered right now in the market. Watch this. Okay, so just very recently, a company called DJI, if you remember what DJI was, okay, DJI Levox. So DJI is a company that simply builds drones. Like it's a pioneer in drone. But recently they get into the market of laser scanner, and this is their product. Watch this. I'm gonna take you to the DJI store, where if you want to buy, for example, Mini 2 or Mavic, you can go there. Please take a look. One, two, there is 5 different models of a laser scanner, and those are 3D laser scanner. Do you see the price? This guy, for example, which is called Levox Mid 40. Do you see the price? This is a laser scanner which is 600 US dollar. And if you add data cable and power cable, so this will add another $100. So it's like 700 US dollar, which is roughly about 1,000 Canadian dollar. You can buy a 3D laser scanner right now. And remember the numbers I mentioned in my class. We start from $120,000, which is the B20, and then BLK 360 was about 23,000 Canadian dollar. And then right now, DJI is telling us you can buy a 3-dimension laser scanner for 1,000 Canadian dollar. What do you think about this one? It's a big game. It's a big fight. Everyone is wanting to win. Big fight between photogrammetry laser scanner. I would say with these new sensors, very compact, very efficient, very affordable, laser scanner will come back to life again. That is what I wanted to say. And there you have it. Any other question for me, guys?
Oh, why was there color on both of those images? I thought we said that the laser scanner doesn't produce color.
Which one you're referring to?
Like when you had the two action figures side by side, I kind of expected one to be colored, the photogrammetry, and I expected the other one to not be.
Is that the slide? Which on the slides you mean?
It was on the video when he compared the two action figures side by side.
Again, as I said, like, those sensors where they have internal camera. So as they do the scan, they kind of go back to the image and make the image color and put it back on the XYZ, kind of bend to brush. So they take the point that has XYZ, they bring it back to the scanner. It hits the image in one point. For example, it's green. They go back to the 3D and color the point with the green color. So you get kind of a 3D texture model. But again, this is not coming from the 3D scanner. It comes from the fact that every 3D scanner, it has a built-in camera.
Okay, thank you.
No problem. Okay, any other questions for now? Okay, so I'm hoping this part was interesting for you. Very important for CVT to understand all those new technology, because if you graduate and you start working with those, data, you should familiarize yourself with all the new technology. Okay, so it was interesting to teach you guys the photogrammetry laser scanner. Next class is the start of our very, very important part of our course, which is about GIS. You will not hear anything about GIS outside my class. Especially for you guys are construction management, you probably need to hear a little bit about GIS. So in the next class, we start our GIS, which will go about 6 classes, like 3 weeks, and this will pretty much finish our semester. So because this will end probably the second or third week of April, so that's very close to your final exam. The 6 classes of the GIS, I will focus mainly on the software. So we have ArcMap or ArcGIS. That is our software that we will learn in this part. Please make sure that the ArcMap is working on your laptop. We sometimes get 1 or 2 students, they have a trouble with the software. If I remember correctly, I sent you an email before even the start of the semester. I asked you to try and to see if you have any problem with your Civil 3D and ArcGIS. Because right now, if any one of you has a problem, I doubt we can do anything for him or her, because simply IT, doesn't work very quick as we do. And that's why if we figure out the problem early on, then we should have a smooth training. Anyway, so we have 6 classes for GIS. 2 of them only 2 classes will be theoretical. Only 2 classes, which one of them is going to be on Friday for you guys. It will be Thursday. So for Thursday, we'll start the GIS. It will be pure theoretical, but the following week, you will have a training on ArcMap. Okay, so get ready and make sure that you have a ArcGIS is working. Okay, thank you so much and have a good day.
Thank you.
Thanks.
Thank you
Have
so
a good
much.
day.
You too.